So this is some background notes on organic chemistry, or AP. Do note that organic chemistry is really not a topic on the AP exam, but I still teach it because there are a lot of interesting molecules that are organic that you will be seeing this year. So that's why I gave you the summer homework, and that's why I start with this. We're only going to look at just a few little highlights of organic chemistry. So hydrocarbons, please understand that that is carbon and hydrogen in the molecule only. Carbon is unique in the fact that it makes 4 covalent bonds. So it has what we call a tetrahedral shape. And again, remembering your shapes, we will get to that sometime this year. So it makes 4 bonds. And again, it's on a flat piece of paper here. But really the bond angle between hydrogen and hydrogen here is about 109.5. It's a very distinct shape that you find in nature. It's a pretty prevalent repeating pattern. We will be discussing that as we go along. But again, hydrocarbons are carbons with hydrogens. So we have what we call saturated and unsaturated bonds. Saturated means you have 4 single bonds around each carbon, and unsaturated means you have less than 4 bonds. So if I have a saturated bond with carbon, this is what it would look like. If it is unsaturated, this is where you could get what we call a double bond or a triple bond. So this is going to be your category of unsaturated carbons. So we have 3 basic hydrocarbons: alkanes, alkenes, and alkynes. So alkanes are what we call the single bonded molecules of carbon and hydrogen. Alkenes has at least 1 double bond. And alkynes has at least 1 triple bond. So what makes something an alkane is the fact that you have a certain number of carbons with a certain number of hydrogens. So there is a formula that you can know, CnH2n plus 2. So however many carbons you have, you multiply that by 2 and add 2. That's going to tell you how many hydrogens you have. So if I have 3 carbons and it's an alkane and everything is single bonded, I'm going to take 3 times 2 is 6 plus 2 is 8. So I have C3H8. So I could draw it out. So I have a single bond between each carbon, and then I have my hydrogens on each one of them, okay? So that adds up to a total of 8 hydrogens in that particular alkane. So you could use that formula to figure out if it's single bonded or not. If you have 1 double bond, and we're just talking 1 double bond for our discussion here, it's going to be a CnH2n. Now that is a formula for a cycloalkane as well, but that's something else that it's not going to be a huge emphasis for our discussions here. So if I have 3 carbons and it's alkene, and it has a double bond, that means it could only have 6 hydrogens in it. So if I draw a double bond between 2 carbons and 1 more carbon, this carbon here on the end, because it already has 2 bonds, can only have 2 more bonds with hydrogen. And then the one in the middle, the carbon that you could call in the middle, I have a double bond and a single bond. I could only have 1 more bond there, okay? It can't go beyond 4. And then hydrogens over here on the end. So then you end up with 6 hydrogens in that structure. And finally, if I have a triple bond, it's going to be CnH2n minus 2, H2n minus 2. So if I have 3 carbons, I'm going to take 3 times 2 is 6 minus 2 is 4. And that's because if I have a triple bond in there, that really limits how many hydrogens I really need in that molecule. So if I have a triple bond here, this carbon needs 1 more bond. Okay, again, the magic number is 4 for carbon. It wants 4 bonds. Carbon in the middle here has 3 and then 1. It doesn't need any hydrogens. And then I have the hydrogens on these carbons here. Okay, so that's what makes it an alkene. So for our discussions of alkanes, alkenes, and alkynes, I'm going to go briefly into naming, just because if you see some of these molecules At least it won't be completely foreign to you. But again, I'm not going to emphasize anything about that. So there are some prefixes that you hear a lot of times in chemistry. It has to do with a number of carbons. And so if I have an alkane, the alkane is going to end in ane. So you're going to use the prefix and end it in ane if you have 1 carbon and 4 hydrogens. So on and so forth as you see down through the formulas. So if I am naming alkenes, a double bonded molecule, they're going to end in ene. Okay, so if I take a molecule that we drew before with a double bond and I have 3 carbons, 3 is always going to mean prop, okay? But this is going to be named propene because it has a double bond. But the additional thing that you have to worry about happens to be that double bond. Well, where can that double bond be? It could be in multiple locations. It's called an isomer, which we will mention. So I always start numbering a molecule wherever that double bond is. So I'm going to use a numbering system to tell the reader where that double bond is located. So this is going to be called 1-propene, okay, 1-propene. Now, if I were to draw the double bond here, is that a different molecule? Actually, it's not. It's just flipping of that. Because in the naming system of organic chemistry, you always start numbering where you have that double bond. Okay. Now, if I have alkynes, these are going to end in YNE. And again, you're going to pay attention to where that triple bond is located. So if I just start with the simple 3 carbons here, again, I'm going to label it 1, 2, and 3. It's not going to be named propene. It's going to be named propyne. And again, I might be mispronouncing that, YNE. And I have to tell the reader where it is located. So it's a 1. Well, where it gets more interesting is if you have more than 3 carbons, okay? So let's say I have 4 carbons and I put the triple bond there. Well, it's between the 2nd and the 3rd carbon. So the 2nd carbon is the number you're going to put in front. You always pick the number that is the smallest number when you're naming it. And this is 4, so if I go back to my chart, 4 is bute, okay? So this is going to be 2-butyne. To tell the reader it's a triple bond and it's between the 2nd and the 3rd, okay? So continuing on with this, okay, where I put that double or where I put that triple bond is what we call an isomer, okay? So it has the same formula, okay, number of carbons and hydrogens, but it has a different structure. So if that's the case, I have what we call a branch chain system, okay, versus a straight chain system, okay. So this is a straight chain, meaning I have all 5 carbons in a row, while here I have what we call a branch chain, okay. I have a carbon off of another carbon here. So if I look at a straight chain and I see how many I have, and let's say they all have the hydrogens, I'm kind of eliminating the hydrogen just for speed here. I have 5, so 5 is going to be pent, okay, so this is going to be called pentane. Well, this has the same number of carbons and hydrogens. It's actually the same formula, but what is different here is the fact that I have a branch here. Okay, so the branch is going to change kind of the naming system that we have. So where that branch is located is where I'm going to start the numbering process. So I'm not going to start numbering from left to right. I'm going to start over here on the right. So it is off of what we call the 2nd carbon. And with a branch, I'm going to use a YL to do a naming system for the branch. So this is not pentane. This is 1, 2, 3, 4. So I have 4 of them. So 4 is going to be butane at the end. But I have to tell the reader that I have a branch off of the 2nd carbon. Well, the 2nd carbon, this is a methyl group because I have 1 carbon off of that. So that is what we call a 2-methylbutane. So these are both C5 H12 formulas, okay? So if I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I have 12 hydrogens here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 there as well. So they both have 5 carbons and 12 hydrogens, but their structures are very different. And in terms of their chemistry, that's going to change how this reacts. So if you see a branching system, and it was in your notes, that's where it's coming